Yesterday we looked at what a system of equations is. We solved systems by inspection, which means we looked at a graph and we told what the solution is, and then we checked to see if a point was a solution by plugging it into the two linear equations to see if that point was on both lines. Today we're going to solve systems by graphing. We are going to learn three main ways of solving systems. You will probably by the end know which one your favorite is. There are sometimes one way is better than the other, but we're going to start by graphing. Okay? So we have a linear system here. It says negative 5x plus y equals 0 and 5x plus y equals 10. What form are these two equations in? They are in standard form, right? So we're going to graph these. I do want to point out, you may have seen when you did the Global Scholar last week, you may see it in other places. Some people that write systems will give this little squiggly bracket here just to show that these two linear equations go together. Okay, so that's what that bracket is. It's just saying here's a system, here's two linear equations that go together. Now, if we're going to graph, what way do we usually prefer to graph? We usually prefer slope-intercept form. Not always. We could graph these two pretty easy using intercepts, but we tend to go to slope-intercept form just because we know that works most every time. So we've got to put these in slope-intercept form. So our first equation is negative 5x plus y equals 0. I'm going to add 5x to both sides. We've done this over and over and over. And we get y equals 5x plus 0. We don't write the 0. What is the slope of my line? 5 over 1. What's the y-intercept? 0. So I'm going to plot my y-intercept. Notice the scale of my graph is 2, so that's going to affect how I count here and what I do. I'm counting by 2s, so I go up 2, 4, 5, and I go over 1, so I have to go halfway, right? So 2, 4, 5, and then over 1, which is halfway, since my scale is counting by 2s. I can do it again, I believe. I can go up 2, 4, 5, and I can go over 1, and I would be right here. So here's my first line. My first line for y equals 5x. Now, let's look at the second line. Let's take 5x plus y equals 10. Let's move that 5x over to put it in slope-intercept form, and I get y equals negative 5x plus 10. So what's my slope? My slope is negative 5 over 1, and my y-intercept is 10. So I plot my y-intercept. I have negative slope this time, so I'm going to go down 2, 4, 5. I'm going to go over 1. Notice that it crosses that line right there. And then I'm going to do it again. Down 2, 4, 5, over 1. I'm right here. And there's my second line. Now, the goal of solving a system is you're trying to find the point that is on both lines. You are trying to find the point of intersection. It is right here. That's your point of intersection. Now, you will not typically circle that or do anything. You're going to give the coordinates. Your goal is to give the coordinates of that point. So the coordinates of that point are 1, 5. If I were to take 1, 5, like yesterday, if I were to take this and plug it into both lines, it would make both equations true, which means that point is on both lines. That point is the intersection of both lines. That point is the solution to my system. Okay, same thing. They've given us two equations in standard form. We need to graph them. So we need to put them in slope-intercept form. I want you to stop the video. I want you to put both equations in slope-intercept form, and then I want you to turn the video back on and check and make sure your slope-intercept form is correct before you actually graph. All right, I got y equals 1/2 x plus 3/2 for the first linear equation. For the second one, I got y equals negative 2x plus 4, right? Let's graph the easy one first. We've got the slope is negative 2 over 1, and we've got the y-intercept is 4. Graph that line, come back and check it. All right, is that what you got? My line's not real pretty, but I think it'll work, okay? Now, this one, what's the slope? The slope is 1/2. No biggie, right? What's the y-intercept? The y-intercept is 3/2. And it's usually at this point, someone says, Miss Gibbs, I don't know how to graph 3/2. Yes, you do. What is 3/2? What is 3 divided by 2? Huh? It is 1.5, right? Do you know where 1.5 is on the graph? Why, sure you do. So we're going to go up 1.5, and that's where we're going to start counting, okay? So when we go up 1 and over 2, hold that thought a second. All right, I messed up. I knew I had. I didn't go up 1, did I? All right, that's not going to erase. Ignore this point right here, okay? So if I go up 1, I'm now between 2 and 3, and I go over 2, I'm right there, right? Then up 1 and over 2, I didn't go up enough that last time. All right, so this is going to be great, though. This is going to show us later why we don't really like the graphing method. We can do it, but it's not a big deal, or it's not our favorite, okay? So I graph my blue line. Make sure you check that slope. We went up 1, over 2, up 1, over 2. Now, where do these two lines intersect? They intersect right here. What are the coordinates of that point? The coordinates of the point are 1, 2. That's our answer. We wanted to know where they intersected. If we were to plug this point into both equations, it would make both true. Now, I want you to try this one on your own. Put them both in slope-intercept form, graph them, find the point of intersection. I will caution you, pay attention to this one right here. It's got this minus y, okay? I'll work it out, so when you get done, turn the video back on and check your work. All right, I got the point 2, -3. I do want to point out when you graph the lines, actually graph them until they intersect, okay? I will have people, let's say here's their coordinate plane, and they'll put a little bitty line up here, and they'll put a little bitty line down here, and they'll say, Miss Gibbs, they don't intersect. Well, they do because a line goes forever, right? So make sure you actually graph them until they intersect, even if it may appear that they don't. All right, if you have any questions, write them here. We're going to practice with graphing tomorrow.